So this question number 7 says that we have to complete this table. All right, but let us reiterate what we have been saying before. Verifying if multiplying matrices is possible. How do you verify if two matrices can be multiplied? You count the number of elements in the row of the first, you count the number of elements in the column of the second. If the two counts are equal, then multiplication is possible. If not, then multiplication is not possible. Verifying the size of the product, because when you multiply two numbers, you get a product. When you add two numbers, you get a sum. When you subtract, you get a difference. When you divide, you get a quotient. So we are multiplying, so we get a product. So what is the size of the product? Also take note that the product will always have the same number of rows of the first. So you count the number of rows in the first and the number of columns in the second, and that is what the product will have. Okay, so the row controls the rows in the product, and the column control of the second. The row of the first controls the row in the product, and the columns of the second controls the column of the product. Okay, so we have a situation there, P times S. P times S. Let's look at P. P is a 2 by 1, 2 rows and 1 column. S is a 1, 2, 3, 1, 2, 3. S is a 3 by 3. Okay, so first it's write down the size of the matrix. So we count the number of rows in P. P is a 2 by 1. P is a 2 by 1, 2 rows and 1 column. S is a 1, 2, 3, 3 by 1, 2, 3, 3 columns. S is a 3 by 3. Is multiplication possible? So let's count the number of elements in the row of the first. How many elements are there in the row of P? 1. P have only 1 element in the row, in this row. It have 2 rows, but each row only have 1 element. You have to be careful with that, Now what about S now? A column. In the column of S, how many elements are in the column of S? 1, 2, 3. So how can you take 1? Here is the first time is the first. But we need another element now for the second. So 1 in the row of the first, 3 in the column of the second. So multiplication is not possible in that case. So no product. Okay, multiplication is not possible. Another way some persons say, just compare the second number with the first number in the sizes, because this is a 1 and a 3. Those two numbers, they have to be equal. If they are equal, then multiplication is possible. If not, multiplication is not possible. All right, so therefore now you have 1 element in the row of the first, and you have 3 elements. Look in there, 3 elements in the column of the second. Multiplication is not possible. Let's look at T. T is a what? T is a 1, 2, 3, a 3 by 1, 2. T is a 3 by 2. Another T again. T is a 3 by 2. 3 by 2. Can we multiply T to T? Let's count the number of elements in the row of the first. 1, 2, which is that 2 there. Okay, 1, 2. Number of elements in the row. Look, the row, 2 elements in it. Now, what about the column now? 1, 2, 3. 3 elements in the column, which is that number there. So you have a 2 and you have a 3. So you have to look at those two numbers. They have to see this side by side. They have to match. because it's telling you 2 elements to 3. First, second. What about the third now in the column? To what number it's going to multiply? So no multiplication is not possible. No product. T cannot multiply to itself. Okay, T cannot multiply to itself. What is the size of Q? Q have 1 row and 1, 2, 3 columns. Q is a 1 by 3. 1 row and 1, 2, 3 columns. S now, S has 1, 2, 3 rows and 1, 2, 3 columns. So those two numbers there, you see how they're close to each other? They match it. So multiplication is possible. Let's just prove it. Count the number of elements in the row of the first. 1, 2, 3. So we need 3 elements in the column of the second. Look at column of the second. How many elements are there? 1, 2, 3. So first to first, second to second, third to third. Yes, multiplication is possible. All right. Now, what about the product now? Because the first matrix has 1 row, that's that number there. So now you're going to look at the outer numbers now for the size. 1 row, so the product will have a 1 row times 3, 1, 2, 3 columns. Yes. So to look for the size now, you have to look at those outer numbers. 1, 1, 3, 3, or 1 by 3. 1 row and 3 columns. So the size of the product will be a 1 by 3. Okay. So I'm just showing you 2 ways to verify multiplication is possible and 2 ways for the size itself. Okay. Because you can use the size of the matrix to verify and also to find the size. S times S. S we say is a 3 by 3. A 3 by 3. Again, S is a 3 by 3. Okay, 3 by 3. No, those two inner numbers matching. So most likely yes. All right, let's verify. How many elements in the row of the first? 1, 2, 3. How many elements in the column of the second? 1, 2, 3. So yes, multiplication is possible. Those two inner numbers here. Yes. So once those two inner numbers, sometimes if they don't give you the matrix itself and they just give you the sizes. You know, sometimes they don't give you the matrix and they give you the sizes. You can use that to your advantage also. So just look at those two inner numbers, and if they are equal, yes. If they are not equal, no. And to look for the size now, we look for the outer numbers. So inner, outer. Inner to verify, outer for size. Okay. So inner and outer for size. So you're going to get a 3 by 3. Okay. And also, we know for sure the product will have the same number of rows of the first, 1, 2, 3. Same number of columns of the second, 1, 2, 3. So it's a 3 by 3 you're going to get. Okay. R. R is a what? R is a 1, 2, 3, 1. R is a 3 by 1. S. S is a 3 by 3. We said that already. Okay. Is multiplication possible? Just look at those two inner numbers. No. Let's verify. Let's look at the matrices themselves. So if you don't have the matrices themselves and that's what you have, you can work with that, you know. Just look at the two inner numbers. And as you can see, they're different. No. But let's verify. Where's R? Look R there. How many elements in the row? 1 element in the row. In the row have only 1. Each row have only 1 element. You're going across. 1, One element in the row. S, how many elements in the column? 1, 2, 3. So one element cannot multiply to 3 elements. Okay, so multiplication is not possible. And if multiplication is not possible, there is no product. Okay, so if you have the matrices themselves, you can count the number of elements in the row and count the number of elements in the column. If you have the sizes, just look at those two inner numbers and you're good to go. All right. Let's check out P. P is a 2 by 1. 2 rows and 1 column. T is a 1, 2, 3, a 3 by 1, 2, a 3 by 2. So we're looking at the sizes, those two inner numbers there, they are different? No. Looking at the matrices themselves, let us prove it. P, how many elements in the row? Only 1. How many elements in the column? 1, 2, 3. Multiplication is not possible. Okay, so no product. What about T times S now? T times S. So T now is a 1, 2, 3, a 3 by 1, 2, 3 by 2. No. T, but I have T there and I have R there. I have T there, so what I have to put there is a T by S. And S now S is a 1, 2, 3. S is a 3 by 3. We see that already. We look at those two inner numbers there. A 2 and a 3. No. Let's verify by looking at the matrices themselves. Let's look at T. How many elements in the row of T? 1, 2 elements. What about the column of S? 1, 2, 3. So multiplication is not possible. A first times first, second times second. But what about the third number times the, you understand? The third number. So something is missing, so multiplication is not possible. Okay, so that's how you complete that table that you have. There are 2 ways to verify if multiplication is possible, and there are 2 ways to get the product.